Hi there folks, it's Mike here and welcome to this lesson in SDL2 with C++. And in this lesson we're going to start talking about some more of the advanced parts of application development with SDL2. And if you're thinking about this from sort of a gaming perspective, as I imagine many of you are because you're using SDL2, we need to be efficient with how we manage our resources. So I want to introduce to you the idea of a resource manager here. So let's go ahead and dive in. So what do I mean by this term resource manager? Well, I'm going to go ahead and just write it out here that we have this resource manager. That's our idea that we want to talk about today. But what does it exactly mean? So let me go ahead and revisit a previous project we had where we had a textured rectangle. And this will help get other folks familiar if you're just hopping in the series. But here's the structure of our project. We have some source here with two files and an include here. And in particular, we have this textured rectangle interface. So let's go ahead and take a quick peek of that just to remind ourselves what's in there. And we've got the ability to create a textured rectangle from some file path. I'll make this a little bit bigger here. So we're passing in some image every time that we create this textured rectangle. And then we can set the properties. We have a destructor that remembers to do the right things, and maybe some helper member functions to update and render our objects. And we've also got to take care of our resources, such as destroying our texture, again, when this object is finally destroyed. So not too bad here. But what I want to go ahead and do is go ahead and open up on our source file. So let's open up the implementation of textured rectangle, and let's see the work that we're actually doing here. And the very first thing that we're doing in this constructor every time that we load this textured rectangle is loading an image. Now, what is this image that we're loading from disk every time? And I'll go ahead and display it in our images directory, because we only have one file, but it's this file here. And you can see it takes up quite a bit of my screen here. It's an image from the Blender Open Movie Project, Big Buck Bunny. But you can see that, this is a rather hefty image. And in my program, if you recall, and let's go ahead and build this with our build script. And if we go ahead and run this, I'm loading this image 10 different times here. You can see it's overlapped. Here's one copy, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th, overlaid on top of each other here. That I'm doing the same work of going to my hard disk, seeking and finding the image, and then creating a texture from it, and then immediately deleting that image, only to, for the next image that we load, resync and load it. And, well, we just keep repeating this process 10 different times. What if we could instead just load the image once, keep it in memory, and then just more efficiently create a surface from that one image in memory, and then save time going to disk, and if we need this image again, not having to constantly seek to the disk. Seeking to our disk tends to be a very expensive operation. So this is where a resource manager comes into play here. So go ahead and close out our program here, and we'll take a look here. And what I want to actually do is just modify our program ever so slightly here. And I'm just going to put a little printout message here saying which image was loaded. So what I'll go ahead and do is just print out image loaded colon here, and then the file path, and I'll go ahead and print it out as a C string since that's how we are taking in that image. And I have to rebuild, so I'll rerun my shell script, and it's warned me that I need the IO stream library since I'm going to be printing out some message here. So let's go ahead and rebuild here, and go ahead and show that, well, when this program runs here, you can see that clearly I have loaded the image 10 times. So how can we get away with just loading this image one time here? I'm going to go ahead and delete this program here, or close it out, excuse me, and show you how to build a resource manager. And the idea with our resource manager is, let me go ahead and draw this here, is that it's going to be a singleton class. If you need a refresher on this, I'll put a link in the description of this video how to exactly build a singleton or what this design pattern is. But basically, every time that we request some resource, whether that's from, say, the textured rectangle, it's going to come to our resource manager and try to check, is that resource available? If it is, then we'll go ahead and just grab that reference. If it's not, then we need to load from disk. Okay, so that'll be the basic workflow of our resource manager. And we're going to do this as a singleton class because it's an easy way to just access everything globally in our program. And we might want to otherwise think about how we would want to manage the lifetime of our resource manager. But again, you can read about the sort of trade-offs of singletons in my previous video. So let's go ahead and just do an implementation, and then we can improve it as we go. I want to go ahead and do this a little bit as live code. So I'm going to make my window a little bit bigger here and start drawing or sketching out my resource manager here. So to do this, let's go ahead and start sketching out the interface for this class. So to do that, I'm going to do a new file here, and I'll do it in my include directory. And I'm just going to simply call it resource manager HPP. So let's go ahead and set up our C++ file. If not defined, resource manager HPP. We've got to put in our header guards and end if here. And let's go ahead and create our class here, the resource manager. Okay, and we're going to do this as a singleton, and I'll go a little bit quick just because many of you perhaps have seen a singleton, but I'll slow down a little bit when we get to the portion to talk about how this manages resources. So I'm going to go ahead and make the constructor private here because we don't want to be able to instantiate any of our resource managers. And the destructor as well. I'm just going to leave undefined because we're technically not going to destroy it anywhere. The copy constructor I do also want to avoid because I don't want to make copies of my resource manager. So I'm going to make sure that this is not able to be created. And I also want to avoid the copy assignment operator. Here. And this will actually be the type here that I want to avoid making a copy of. Okay, so now that I've got this class set up for, well, what it can't do, instantiate another version of itself, let's go ahead and think about what it can do. And that would be to think about the public methods. And typically what we have here is some sort of way to get an instance of this resource manager that we're going to allocate and control. So I'm going to go ahead and just create a static function here and return a reference to some resource manager. And usually we call this GetInstance or something of that type. So I'm just going to say GetInstance here. Okay. And now I can have our actual task that our resource manager, and that's going to be to retrieve some particular resource. And what that's going to be is some SDL surface that has loaded in some bitmap here. So let's go ahead and have an SDL surface here. And I'm just going to write a function called GetSurface. And, well, where's that surface going to belong, or how are we going to identify which surface we want? Well, we're going to do that by the file name here, or the file path. And that's sort of the key here, that our resource manager needs some key and needs to be able to return some value. So the key being here a string, and the value being returned the actual surface. So the hint here is that we need a data structure for our resource manager. So let me go ahead and bring in some includes here. So we're using a string. And then we need some hash table data structure, which in C++, the unordered map will do the trick. And this data structure will allow us to, in constant time, look up a key based off of the string and return the appropriate SDL surface for us. Okay, so that means somewhere we need to also be holding a unordered map. So what's our unordered map, or how's the structure actually going to be set up? Well, it's going to be a unordered map here. The keys are going to be strings for the file path, and the values are going to be pointers back to the SDL surface that was allocated. So SDL surface, and it'll be a pointer. And let's just call this, for now, it's a member variable, and I'm just going to call it surfaces. Okay, so that looks like pretty much all that we have. Now we're going to have to refactor anything that relies on our resource manager, which will hopefully be all of our classes that we derive, so that we have a sort of single responsibility or consistent way to access different objects that have been allocated. So we do need to make sure that we're not freeing our surface here. But before I get to that, let's go ahead and talk about our resource manager implementation a little bit in the associated C++ file. So what I'm going to go ahead and do here is go ahead and start our implementation. So let me go ahead and do this to the window above me here, and I'll open up a window here in source, and this will be called resource manager.cpp, as I'm listing here in the bottom left corner. Okay, so we're going to need to include the resource manager header file first and foremost. And let's go ahead and start with our implementation. All right, that's a little bit of typing. Let's go ahead and fix any compiler errors that might have happened. So let's go ahead in our build system. And inevitably, there are some bugs here. So just a moment while I make a few fixes. Just a subtle bug here. So anytime I see this does not name a type, that means, well, this class is missing. So line 1, if not defined in my header guards, that'll improve that bug here. Let's go ahead and give another recompile here and start tackling some of these other errors one at a time here. Looks like I'm also missing some types here. And of course, I have forgotten to include my third-party library here for SDL here. So this path is going to vary depending on if you're doing Windows, Linux, or Mac. For, I believe, Mac and Windows, you should only need the header file. So let's go ahead and recompile here. And let me make sure that I don't mix things up too badly here. This is in the SDL2 directory. Sometimes I forget myself. And now we can continue to work on some bug fixes. And it just looks like my compiler, G++, has done a nice job of just telling me that I'm awful at spelling, as is often the case here. So resource manager. There we go. That looks much better. Let's try to recompile. And just a few warnings here because we're not really returning any type in some of our functions here, so we might want to fix those. And again, since I've made these private here, I might want to eventually implement them should I actually need to do anything, but let's go ahead and just finish off this singleton class here. So in our actual GetInstance function, this is what we care about most, and our GetSurface. So let's go ahead and implement GetInstance. And what this is going to do is instantiate exactly one instance of our class here. Okay, and that's the overall goal because this is a singleton. I'm going to make this just a little bit bigger so folks can see if you're following along here, just above my head. And what we want to do is I'm going to create one static instance of the resource manager. I'm going to create this as a pointer, and I'll prefix this with an S because I like to do that for style, as the instance here. And this will be a new resource manager. So in a sense, I've just statically allocated one pointer to a resource manager. And with static in C++ 11, again, this is thread safe and guaranteed to be only instantiated once, even if I had multiple threads working with this particular function here. So this is good to go. Now, what we're going to want to do then is return our static instance. And we could return just the actual pointer here if we wanted. And I would have to modify my return type. But returning pointers is a little bit dangerous because then the user could delete this particular instance and we'd have to add a bunch of error checking code. So instead, we want to return an actual reference to a resource manager that exists. So we go ahead and dereference here our static instance. So here is our resource manager for setting it up, and it's essentially ready to go at this point. Let's go ahead and think about our GetSurface function here. I'm going to go ahead and start adding some lines of code here so we can start thinking about it here. And I'm going to push it up just a little bit so you can see everything on the screen. Okay, now to do this too, let's go ahead and open up our textured rectangle constructor here, or the one place where we are allocating some resources, because we're going to need a little bit of logic here. And the basic idea is I want to be able to look through my map data structure that's in our resource manager and see if any surfaces exist. So let's go ahead and write that out. So we will look through our M surfaces, which is a unordered map, and see if a file exists. And a file name's a pretty good key. It's unique. We can really only have one file and one destination. So I actually like the idea of using file paths as keys. Maybe we can be more efficient, and maybe you might later explore things like GUIDs or globally unique identifiers. But for now, file path will do the trick here. And if the file does exist, then return the associated surface. Because anytime we load something, we're going to always, in this particular function for GetSurface, allocate a SDL surface. Okay, so let's go ahead and hold on to that idea. You need to play back the video again to capture that, that's fine. Now, otherwise, if the file doesn't exist, then again, we will do this. So if the file does exist, we'll find it in the map and return it. If it doesn't, then we'll actually load our bitmap. Okay, so let's go ahead and start implementing this. And I'm going to start taking away some of the code that we have here. And I'll move that here. And we'll need to figure out how do we search our unordered map. Okay, so how do we actually look through the unordered map? There's a couple of nice pages on c++.com or CPP reference that I would recommend. But the basic idea is we have this data structure, and in the STL, standard template library, some smart folks have done some work for us. I'm going to go ahead and bring this in just to show you again how to use your C++ documentation here. We have the different containers here, and you can see that we have unordered map that's new in C++ 11. And again, it's an associative container with key value pairs here. And we can see some of the different functions that are available to us. I'm going to go ahead and just search for the find here, where we want to, again, find an element with a specific key. So in this way, we can, in the average case, based off of the hash table data structure and how elements are hashed into buckets, find our surface in constant time, which is pretty good. That'll be the most typical case here. So if we go ahead and see how to do this, you'll notice that there is a find structure here that returns an iterator to either the particular element that we're looking at, or will otherwise return null if we haven't found something. We want to replicate this structure in our code. So I'll leave this here for you to study for a moment, then I'm going to take it off the screen and implement it. All right, let's go ahead and do it. So we've got code for finding our surface here. And then let's go ahead and create a iterator here. And this is part of our M surfaces data structure. And we want to find some file path. That's the actual string here. Now, if our search is not equal to M surfaces end here, that means If we didn't reach the end, then we must have found our surface. So we'll go ahead and return at m surfaces whatever the file path was, the string or, again, our key in our map data structure. Otherwise, what we need to do is allocate that surface here. So we'll go ahead and load that surface, and then we'll have to add it to our map. How do we add things to our map? Well, we can use a few different things here. I'm going to go ahead and just show you on the CPP reference site, looking at, for instance, the insert member function, and we can sort of follow this structure here. We can make a pair and directly insert it here. So that's what I'm going to follow. Okay, so in this instance, we're going to create our pointer to our surface and do the actual loading here. So again, we'll take our m surfaces, we're going to insert, and I'm going to go ahead and just use the standard library function for make pair, and this takes our file path and the surface that we created here. So let's go ahead and give this a compile and see if I've made any mistakes or done anything silly here. Looks like we've still got our warnings from our previous functions. So let me go ahead and just fix these here because they are bothering me a little bit here, and they're not really used. So we could just return this object again. And let's see, we have one potential case where this function could fail here on our SDL surface, so I'm just going to return a null pointer in that case here to get rid of all of our warnings. And a best practice to get rid of our warnings. Let me go ahead and leave a comment here because this is going to bother me since I have not properly implemented this function to do, although we do not need this for a singleton. Okay, but we know that that's there. We could delete these member functions, for instance. Okay, so now that we have our resource manager and we've implemented how to search through our map, find our surface based off of a file path if it already exists, or otherwise load that, create a pair, a key value pair with the key as the file name or the file path and the surface, let's go ahead and use it in our textured rectangle here. So what I'm going to go ahead and do is now access through our resource manager here. So we'll need to include the resource manager .hpp. We will always look up our surface, and we won't free it. So that is something that we will have to think about in our resource manager if we want to build in the functionality to free old surfaces or perhaps ones that have been used for a while, and I'll leave that as an exercise for you. But it is something that you do want to consider now that we're managing the resources. When do we give up ownership? Okay, so what we're going to do is access our resource manager. It's part of the class, and we're calling a on GetInstance here. And within some instance, we're calling a particular function here, GetSurface. GetSurface. And that was in our images. Let's see where exactly our images. Just so I can show you here. In the images directory, and then test.emp. So images /test.emp. And this will return our actual surface. So I can create this as a pointer if I want some temporary pointer here. SDL surface, retrieve surface, something like that. I'm going to get rid of this line and just put it in here. I do tend to like to separate out my lines here. Again, I could put this whole call here, and that would be fine otherwise. Okay, now let's see if this actually works, and then we'll show you the savings. So it builds, and in my binary directory, I'll run my program, and we'll see that we actually get 1, 2, 3, 4, 5, 6, 7, 8 9 here. Looks like it didn't quite work, so we do have to fix this just a tiny bit. And it looks like I've made one tiny mistake here in my actual returns here. I was ignoring the actual value that was returned from my warning here. And I should actually just return this surface that we have allocated here for the first time. So that'll be the same pointer that we have here. Or in fact, let me just consistently do this once we add it to our map here and return it like such. Okay, just in case we change our operators or anything. Okay, let's go ahead and do a new build and do a new run here. And now we can see that we should have 10 textured images. Here's the first one, and then you can see a bunch of them stacked on top of each other. 1, 2, 3, 4, 5, 6, 7, 8, and 9 here. So not too bad here. Okay, now, how could we prove to ourselves that this is actually working? Well, we could actually step through the debugger and see that the first time through, it'll execute this in our resource manager. And then the second time through, it should just do our surfaces. Okay, that's what I'd encourage you to do. I'm going to cheat here in a sense and just print out some logging messages here. I'll remove that from our code here. And I'm just going to lazily include this here just for the temporary being here and just print out image allocated once with an end line. And actually this goes in this path here. There we go. Okay, so if I do the build, then this should only allocate the image one time, or we should only see this path taken one time, because we're loading or attempting to load or create a texture from the same surface over and over again. So image allocated only once. I have my program running, and that's pretty cool there. We've essentially saved ourselves loading and keeping in memory 10 times the information. That can really get very large, especially if we have bitmap images. Okay, so there's a lot to unpack here, so I want to take a moment to recap what we've done here with our resource manager. So let me go ahead and clear the board here and do a quick recap. So 1, we were wasting space. And that was the need to have a resource manager. So 2, we created a resource manager. That was our class on this side here. And you can see the implementation on the right side of the window. And this was a singleton, which again, you'll want to think about some of the design decisions you have to make. You know, could you just have one instantiated somewhere where you'll need resources and sort of manage that lifetime? That might be fine. You know, create it as a pointer and then sort of manage it in some other data structure. The other considerations you might need to think about are, will this manage all of your resources, or will you have one just for surfaces? What about textures? What about for other asset classes that you might want to manage? That's, again, a design decision that you'll have to think a little bit about. And then finally, as part of our resource manager, let me label it here, we had a map using file names, or file paths to be a little bit more precise, as keys and SDL surface as a value. And again, just to draw what was going on, is we had some container data structure, an unordered map, that will allocate a bunch of memory here, and it will consist of, in each of these buckets here, I'll draw one down here, a key and a value. Key being the file path, and the value being SDL surface. If we are searching through this particular data structure in any of these buckets, and we find the appropriate key, then we can just return a pointer directly to something that's already been loaded. Okay, so I know this has been a lot in this lesson here. So let me go ahead and just wrap it up here by giving you one final look at all of the code that we have written here. On the left side, here is our interface for our resource manager. And on the right side, we implemented our singleton class and returned a single instance to a resource manager. And we simply had a map data structure here, which I'll get rid of our output, which again loaded resources using file paths as keys and returning a value of whatever we needed, a pointer to our SDL surface in this case. So if you've gotten some value from this video or thought it was interesting, or perhaps want to just engage in discussion in the comments below, please feel free to. Otherwise, like, subscribe, and we'll see you in a future lesson. Thanks for spending your time with me.